Okay, so I'm gonna be presenting my program today. But first of all, I want to show you how I back up my classes. So this is how I back up my classes. I create folder for each one with like different version. So you see the binary search tree. This one is my binary search tree that it doesn't involve a function pointer. So but then this one is the one involve function pointer, and then I create the class for AVL3 also, and then the map encapsulated map class, and then vector without std vector, and then this one encapsulate std vector. Okay, and then move on to the program. So in this program I use AVL3. So I will have like insert function using recursive, and then delete function, search function to search if the element is in order. This one is a pointer function in order, and then vector collector. So what I use in my program, I use BST to store the key from map. Yes, so vector will be the collector to collect the key in BST. Yeah, the key will be returned, and then the root, and then I have successor and predecessor for delete function, and then I have like find height. Find height will involve max to see the maximum. Yeah, and then find balance factors. So balance factor will be used to determine if there is a balance between if there is a balance in the tree. Yeah, if the find balance back factor, if the balance factor is more than 2, means the tree is not balanced. So yeah, we have to do rotate right or rotate left. So if you see here, the rebalance, if the balance factors is more than 1, which means 2, so it will be non-balanced, it's not balanced. And if the data is less than left, mean it is a left imbalance, so it will need right rotation. So by the following, if it's positive, then it will be on the left. On the left will be imbalance, but if it's negative, so it will be on the right. On the right is imbalance. Yes, and then it will be in another condition is left right also. Left right, so it will first rotate left and then rotate right to make it. And then look at my rotate. So yes, so I use AVL3 to store the key of the map, and then we move on to main function. So the main will open the file. It will open this file, and then it will process the file, open the file, and open another file in the file. Another file will carry the actual data, and then the actual data will be passed and then save into the record object, and then the record object will be saved, and then it will create map. The map will then check the year, the first year appear. If the year is not inserted in the map yet, it will create vector for the specific year, and then it will insert the vector into the specific year, and then the BST will insert the year also as a key. It will insert the year as a key of the map, and then the map will this map will return vector, and then the vector will add the element, which is a record, into the vector regarding to the year. Yes, and then we move on to the option. So option will pass the BST and map as a parameter to the option, and then it will be key collector key, which this one will be the key collector to be used in the option. And then get key, compare key for the year. This one will it will return the key from BSC to the specific year that they want. And then option 1, get the key. It will get the key and then pass the key to the map, and then the map will return the reference vector to data sensor, and then data sensor will be processed to here. For this one, it will calculate the average wind speed. Yes, and then it will use the mean function from calculation standard. Calculation template, and then it will calculate standard deviation from calculation template also. Yes, and then for option 2 will use the process. It will use the process helper function. Yes, to calculate the mean and standard deviation according to the given code. Yeah, so if the given code is T, it will calculate the ambient temperature. If the code is SR, it will calculate for solar radiation, and if it's S, then calculate wind speed. So for option 2, we'll use process. It will use process function helper. Yes, for each year, for each month, and then given year also. So option 3, do the same thing. Retrieve the key from BSC using in order traversal, and then and then return, and then here. So for option 3, it will print the Pearson correlation for the given month. Yeah, so that it has to access all the year, all the vector regarding to every year. So here it is. It will retrieve all the vector in map, and then it will add all data into data sensor here, and then it will pass data sensor to SPCC helper function. This SPCC helper function will then calculate. It will pass the codes also for two sensor codes to calculate the Pearson correlation between two data sets. So it is here. So it will be two data sets for two sensor codes. Then we will compare the code 1 and code 2, and then code 1 will store for that first data, and then second data also. And then after inserting data, first data set and second data set, it will pass for correlation, calling from calculation template class. After that, it will return correlation. Yes, and then go to option 4. Go to option 4. So option 4 will retrieve the key again from the year, and then it will pass here. And then if we open the the CSV file, and then it will write output, and then use the print to file helper function. So print to file helper function will be there will be array of sensor codes STE SRs, because it has to process all the codes here, and then it will get the year. It will prompt the year from the user. So then get the year, and then compare the month, and process for each month, calculate mean, and then standard deviation and mean absolute for each month. So, and then it will write for each month, and check the standard deviation if it's more than 0, if it's less than 0, so there is no data, and then done, and then it will keep repeating for each code. Yes, so that's it.